Hi guys, I'm going to do a video on how to complete the square. If you can take out your packet, I'm on page 14, and these are the questions, these are the answers that we went over. I feel like it was a little too fast in class, so I'm hoping you're okay with, we were just factoring. We were factoring the quadratic to find the factors. Before I continue with the handout, I just want to review or discuss why completing the square is a really helpful strategy. So if you have a quadratic in standard form, so here is a quadratic in standard form, and if the quadratic is factorable, I still think that we should stick to the way we were graphing this quadratic on the quiz that you just had. So if they're asking you to graph it, I still recommend that you factor, and I'm hoping I found factor that actually work. They do. And I'm hoping that you rely on these roots, because I'm putting this equal to 0, 7 and negative 1, and you find the midpoint. That's what I would recommend. Another way, because especially when this is not factorable, I'm going to again make up something that's not factorable. And something that's not factorable, like here's an example where this quadratic is not factorable. So if something's not factorable, I guess I can do the quadratic formula to find the roots, but it would be really nice if I had the vertex. It would be really nice if I knew what transformations were done, and that's actually better than doing the quadratic formula and finding the roots. So this is the purpose of completing the square. When you have a quadratic in standard form and you want to turn it into vertex form, that is when completing the square ends up being really, really helpful. Okay, so let's make sure we understand this concept of a perfect square trinomial. So the factors were the same. So this is a perfect square, that's a perfect square. This whole thing is not a perfect square because there's a 2 there. If this was a 4, then it would be a perfect square. And so these trinomials are special trinomials. I had to really think about the last number, the constant for each term, to make sure that when you factored, you got a perfect square. So we talked about this before in one of the previous pages of our packet. This 9 comes from 6 because a half of 6 squared is 9. So half of 6 is 3. 3 squared is 9. This is why this is called a trinomial that produces a perfect square. Half of 8 is 4. 4 squared 16. Half of 2, we're just taking the 2. Half of 2 is 1, and 1 squared is 1. Even if you looked at the negative 2, half of negative 2 is negative 1, and negative 1 squared is positive 1. So pause the video, go find the value of C that makes each trinomial a perfect square for number 4 and number 5. Pause the video and try it yourself. And then when you're ready, start the video again, and I'm going to show you the answer. So for this one, half of 22 is 11, and 11 squared is 121. And so I'm just checking, not that the question asked for that, I'm just confirming that when I factor x squared minus 22x plus 121, that I do get a perfect square as a factor. Number 5, half of 5 is, well, half of 5, 5 over 2. And 5 over 2 squared, you can go and work this out. 5 over 2 squared is 25 over 4. And this is me really quickly checking to make sure that when I factor this, with C being 5 halves squared, that this is the factor I get. Okay, let's get started with number 6 and 7. Read the directions. The directions want you to go change that quadratic that's in standard form and turn it into vertex form. While I get my paper ready, you should look at the constant. Maybe the constant is the constant that we need. Maybe we don't have to. Maybe we don't have to complete the square. So half of 18 is 9, and 9 squared is definitely not minus 2. This is not the constant I want. if I want my factor to come out to be a perfect square. So there's a bunch of ways of doing this. This is how I do it. I'm going to leave the -2 sort of at the end, and I'm going to insert that 81 that I want, because a half of 18 is 9. 9 squared is 81. I'm going to write it as 9 squared. And so, but this is cheating. This is not allowed. I can't take the original problem that the teacher gave me and just insert an 81. So the good thing is that if I subtract 9 squared, so these two numbers in the red, they just add up to be 0. I added 0 to this quadratic, and I'm so allowed to do that. So one more time, if I'm going to put 9 squared, I have to minus 9 squared, because technically, well, not technically, but really in actuality, I just added 0. We complete the square, we factor this trinomial, and the factors come out to be x minus 9 squared. This is why I did not put an 81 here, because I wanted the 9 as my constant. And then here, let's add those or subtract those terms. -2 minus 81 is -83. And this is my answer. And this is vertex form for number 6. All right, rule for completing the square. Completing the square only works out nicely if your leading coefficient's 1. If your leading coefficient's 1, then completing the square works out nicely. I'm looking at number 7. The leading coefficient is not 1, it's 2. You can complete the square, but there's an extra step that you have to take. So let me take out the greatest common factor to be 2. I'm going to do some scrap work on this side. If I take a greatest common factor out to 2, because maybe it ends up being a problem like number 3. Remember when I took out a greatest common factor of 2? Then I was able to take this trinomial and factor it, so the factor was a perfect square. So if I take a greatest common factor of 2 out, I get x squared minus 14x minus 8. Half of 14 is 7. 7 squared is 49. This is not what I want. So I have to complete the square. Again, there's a bunch of ways of doing this, and this is how I want to do it. Or this is how I do it. I'm going to take a greatest common factor out of these two. Like, I'm not liking the -16, so I'm going to isolate the -16, put it really far away because I'm not liking it. And then I'm going to take a greatest common factor out between just the first two terms. And this is the greatest common factor between the first two terms. All right, now let's complete the square. Half of -14 is 7, 7 squared. And now here's the part where you have to be careful. I did not add 7 squared. I am not going to put down minus 7 squared. I technically added 2 times 7 squared. So I just inserted in my problem 2 times 7 squared. That's what I inserted. And that's cheating, and that's not allowed. But if I subtract it, then it's okay. So again, the 2 times 7 squared is 49 times 2, whatever that is, and that's positive. But if I subtract it, then I'm good to go because it's as if I inserted a 0. So here's my 2. Let's go factor this trinomial. It's x minus 7 squared. And then go grab your calculator and do -16 minus 49 times 2, and that's your answer for the y value. Okay, I'm going to stop here, and the rest of the video, the rest of the packet, we'll do in class. Again, sorry for being lazy right now, but you can sort of work out this computation to figure out the y coordinate of the vertex.